Hey, gentlemen, how are you? I want to go over a problem that's very similar to the number 35 in the homework, that will be similar to a quiz you're going to take later this week. So I can't believe I'm doing this as a St. Joe's U graduate, but here is some data from Villanova. I taken cut and paste it straight uh, from their admissions website, and there are two important bits of information. One, the middle 50% SAT score. Right, so this is, of course, test optional, so it's just the people who reported SAT scores. The middle 50% was from 1400 to 1500. So I want to consider taking a simple random sample of size 50. So first I want to consider all possible simple random samples of size 50. And we know that's called the sampling distribution, right? And I want to look at not sample means, but sample proportion, so p hats. So for example, I might take one sample and get 30 people who have an SAT score above 50, greater than or equal to 1500. In that case, that p hat would be 30 over 50, so 0.6. So I want to describe the sampling distribution: shape, center, spread. And I won't go in that order. The center, so the mean of the sampling distribution, mu sub p hat, is always going to equal the mean of the population proportion for p hat, because this is an unbiased estimator. So it's going to be equal to p. And what is p in this case? Well, if the middle 50% goes from 1400 to 1500, then the third quartile must be 1500. So it could go, there could be lots of people with 1500, but it's going to be about 0.25. 25% of the students are going to have at least a 1500. The standard deviation of p hat. Well, for this one, we have a formula, and that formula is PQ, well, Q is 1 minus P, radical PQ over N. But when are we allowed to use this formula? Right, there's a condition called the 10% rule. We can only use this this standard deviation formula if the population size is at least 10 times the sample size. This is similar to when we were talking about binomial distributions, and we were talking about them being approximately normal, and they had certain conditions, but also the conditions for there was a condition that said, hey, the probability doesn't have to be the same time, the same thing every single time. In other words, you can sample without replacement, as long as you had a big enough population that you were sampling from, so that as you took an individual out of the population, it wasn't going to affect the probability that much. For example, if I say 25% of 10,000 people have a certain SAT score, if I take one person, I get one success. Well, now there's one less person in the population, and the population size, the remaining people to choose from, has gone down by one. If my population is big enough, that's not going to be affected. So this rule is very similar to the rule we had with the binomial distribution. Okay, so we know the center, we know the spread, and we know that we're allowed to use this standard deviation formula. The shape, well, the shape is normal as long as we satisfy certain conditions. We need NP to be at least 10, and we need N times 1 minus P to be at least 10. So our sample size is 50. The probability of getting an individual with a 1500 or higher is 0.25. That shouldn't be 500, that should be 50. I'm sorry about that. So that's 12 and a half. Well, that's just bigger than 10, so we're safe there. We're going to get at least 10 failures. Let's see. Sure, 50%, 50 times 75% is 37.5. That's also greater than 10. So we satisfy this normality criteria. So now we're able to describe the shape, the center, and the spread of this sampling, this particular sampling distribution. So an interesting question might be, hey, I took a sample of size 50 and I didn't get 25% of the people with an SAT score that high. What gives? So let's just pretend that I took a sample of size 50 from this population, the admitted NOVA students who submitted SAT scores, and I got 10 out of 50, or 20%. I mean, it's a p-hat because it's a sample proportion, right? So I might doubt the claim that p does in fact equal 0.25. So the question is, well, how likely am I to get a sample proportion this small? In other words, assuming p really is equal to 0.25, and the sampling, therefore, the sampling distribution of p hat for samples of size 50 is normal with a mean of 0.25 and a standard deviation of radical 0.25. We never actually calculated this in the previous step, which we should have. So assuming that's true, what is the probability of getting a particular p hat that is as small or smaller than 0.2? Well, luckily I brought my my TI-89 home with me, so I can do these calculations. Well, first, this standard deviation calculation. This comes out to 0.06123 7. Obviously that's rounded slightly. So I want to consider this normal distribution centered at 0.25 with a standard deviation of about 0.06. So 0.20 is not even quite one standard deviation away. So what is this shaded area? What is the probability of being less than 0.20? So on my calculator, I will go to either shade norm or norm CDF. That's under distributions. My lower value, it's not going to be 0. Right? It's going to be negative infinity. Because the normal distribution is continuous. It goes off to infinity in both directions here. So lower value, negative infinity. The high, 0.2. The mean, 0.25. And a standard deviation of 0.06123 I could even type the expression radical 0.25 times 0.75 over 50 if I want to be a little bit more precise. All right, so I graph that, and I see a picture that's shaded just the way I shade it, my normal curve, and I get a probability of 0.20710. So that's telling me that there is a 20.7% chance of getting a sample proportion as small or smaller than the one that I got. So that seems kind of likely. I wouldn't be concerned. I wouldn't doubt. I wouldn't doubt the original assumption that p equals 0.25 if I got a sample as small as 10 out of 50. So that's just a problem that's modeled off of number 35 from your homework, and you're going to have a quiz question that's similar. Right? You'll describe the shape, center, and spread of your sampling distribution. You'll check conditions, 10% rule for standard deviation, the large counts rule for normality, and then you might have a specific example that you're going to check against and see how likely is it that you'd get a sample proportion as extreme as the one that you got. So you just do your normal calc from there. All right, good luck with that, fellas.